Imagine looking into a mirror that doesn't just reflect light but time itself, a mirror that doesn't show your own face, but the very dawn of existence when the universe had barely begun to breathe. That's what the James Webb Space Telescope was designed to do, but when it gazed deeper into the cosmos than any instrument before it, it didn't find the expected infancy of the universe. It didn't find the cosmic cradle. It found a contradiction, a revelation so profound it's begun to unravel the very framework of modern physics. For decades, scientists believed they had the story of the universe's birth mostly figured out. First, the Big Bang, then a dark age, followed by the slow emergence of light-simple particles gathering into stars, stars clustering into galaxies, galaxies forming the backdrop for life, and the deeper we looked into space, meaning further back in time, the simpler things were supposed to be sparse hydrogen clouds, scattered particles, chaotic, unstructured beginnings. But then Webb turned its golden mirrors toward a quiet, forgotten patch of sky, one of those seemingly empty dark corners where nothing remarkable was expected, and it found something impossible: galaxy. Not a blurry smear, not a loose collection of gas, but a massive rotating structure of stars, not just existing, but thriving. At first, it seemed like a fluke, but more data followed. More galaxies emerged from that ancient darkness, mature, chemically rich, and gravitationally stable. It was as if the universe had fast-forwarded billions of years, skipping its awkward infancy and leaping straight into cosmic adolescence. And with every new image, one unsettling question grows louder. What if everything we thought we knew about the beginning is wrong? When the James Webb Telescope first captured that now famous image of a galaxy over 13 billion light-years, astronomers expected just a faint blur, a whisper from the edge of time. Instead, they got a roar, an ancient system that shouldn't exist, yet does. Elegant spiral arms coiled like ribbons of starlight, dense clusters of stars orbited in near-perfect harmony, and, at the heart of it all, pulsed a brilliant, energetic core. This galaxy wasn't forming, it was fully formed, and not just recently. It looked like something we'd expect to find several billion years into the universe's evolution, not a mere few hundred million years after the Big Bang. To grasp how truly unsettling this is, you have to understand how galaxies are believed to take shape. In the early universe, matter was sparse and scattered, slowly gathering under the pull of gravity. Over eons, these clouds collapsed into stars, which then merged into galaxies, a process thought to span billions of years. But what the James Webb Space Telescope observed shattered that timeline. This galaxy hadn't just taken shape, it had flourished. According to every known model of astrophysics, this should be impossible. It was like stumbling upon a towering redwood tree fully grown in soil that had only just been planted. Even more unnerving, this wasn't an isolated case. Webb identified multiple galaxies across different regions of the sky, all displaying complexity, structure, and maturity that defied everything we thought we knew about the early cosmos. This wasn't an instrumentation error. The telescope was performing flawlessly. What was failing was our understanding of the universe itself. And then came the spectral data, the elemental fingerprint hidden in the light from these galaxies. What that revealed sent another shockwave through the scientific world. These galaxies didn't just exist, they held chemical signatures of elements that by all logic shouldn't have been there yet. Oxygen, carbon, even iron. These elements aren't primordial. They're not part of the universe's original makeup. They're forged inside massive stars, created in their cores through nuclear fusion, and only released into space through cataclysmic supernova explosions. That process takes time. The earliest stars, known as population 3 stars, were made of only hydrogen and helium. They had to live, burn out, die in violent explosions, and scatter their contents across the cosmos. Only then could second-generation stars form, enriched with heavier elements. That entire stellar life cycle was believed to take hundreds of millions, if not billions of years. But here they were, galaxies less than 400 million years old, already showing evidence of multiple generations of stars having lived and died. If that's true, it means the universe didn't just gradually awaken from the Big Bang, it erupted into motion, forging, burning, exploding, racing through cosmic evolution at a pace no one had predicted. And the presence of these elements hints at something even more profound, because they aren't just the ashes of ancient stars, they are the ingredients for life itself.